So today we're just going to run through probably one of the biggest misconceptions in the industry. What is a bond breaker and how they get used and what people think of actual bond breakers compared to what they really are. Welcome back, Rob.
Thanks there, James. Good to be here.
Nice to see you again.
Yeah, it's always good to see me.
Yeah.
If you're not looking at me, you're not looking at enough.
So we're just running this podcast today, and Rob is going to give us his knowledge about what's been happening in the industry, how people are misusing bond breakers where they're actual fillet joint sealants or where they're actual transition tapes. And let me ask you something. If your membrane can't move it, is it really a bond breaker, Rob?
Well, that's right. If it can't release from the actual system, is it really, if it can't break its bond, that's why they call it a bond breaker. Is it really a bond breaker? Well, the way that I see it, well, no, because it's no need to break its bond. It's not a bond breaker. Anything paintable really isn't a bond breaker because it's bonded to the material itself. As you said, it's one of the biggest out there in the industry misunderstood parts of the systems that's actually installed in the waterproofing system. I mean, like at every transitional or directional change internally, we require, whether it be a bond breaker or a fillet, for the transitioning of the membrane. Now, we're not even getting to the membrane yet and what the membrane requires in regards to assistance in that directional change. We're looking at the actual part of the system which is referred to as the bond breaker, and its design requirement. And I think that if people understood, one, the process of what a bond breaker is, two, what it actually does and what it's needed for, and three, be able to visualize what's required at that transitional change, they'd have a greater understanding of how the bond breaker needs to work in your waterproofing system.
But every time you go to a job site, every time you speak to someone, 80 or 90% of the people, they're saying, oh, we installed a bond breaker. Yeah. But they're locking the membrane in to that sealant or whatever tape that they've been using. They're saying, okay, this is a bond breaker, let's move forward. Or that's what they've been taught or heard down the line of waterproofing whispers. Oh, this is a bond breaker, this is what we're going to do with it. How's that misconception got to that point, Rob?
Well, as I said, once again, it's, I don't know, I call it ignorance. And it's not that ignorance is a bad thing. It's just that ignorance is, people aren't learnt. Okay? I mean, and that ignorance can in time lead to arrogance where people don't give a rat's. Because they think, oh, yeah, I've got something there. It's going to be covered by all these other layers and stuff like that. And, how much room, and here's the key, how much movement do I really have to accommodate? Okay, and that's what the big thing is there at that transitional change. It's movement accommodation and the movement accommodation factor of your system and how it works with whatever amount of movement's there. Now, the thing is if it doesn't release, how does it really accommodate that movement? And this is why there's design criteria and stuff like that in regards to what you're using in those areas for it to work and accommodate that movement. Yeah. See, the way that we build today, one of the biggest things that's out there in the industry, because we're in such a hurry, is movement accommodation. And we'll build a building and then we'll drill a tunnel under it, because that's the way we are. We do things backwards, but yeah, then you've got all those vibrations and stuff like that. Whereas the system above it or the building envelope above it have those movement areas being accommodated for with whether it be a sealant or a silicone or one of the bandages, has that movement actually been accommodated for, but more importantly accommodated correctly? And most of the times, and what we're experiencing out there, no, because people just don't know.
No, they don't know. They've misunderstood the reason of a bond breaker and a joint sealant. So it's the bond breaker that's the confusing part, Rob, from.
Yeah.
So in a general term, what's the easiest way to let people know what a bond breaker is?
Well, look, if they don't know how it works, it becomes very hard to let them know.
Yeah.
Or to actually show them, what I need, because it's very misunderstood, is I actually need a prop where I can show them how it actually releases when there is movement. Because, if you're trying to see the movement of one of these, or how this bond breaker works, most of the time the buildings fail and you've peeled it out because of the failure. You say, okay, there's a failed bond breaker. Why? Well, because it weren't able to accommodate the actual movement that's there. But if you don't make it like in a prop form, you can't really show the individual in what the message that we're trying to get across, and how this thing is supposed to release when there's movement, and then work accordingly. There's so many intricacies within that design, but once you know, you know.
If you know, you know.
Well, yeah, but there's a lot of not knowing out there, not understanding.
So, in a common sense, they would put their primer coat. They would allow their primer to dry. They would put their bond breaker. Then the waterproofer, or whoever's doing the waterproofing, would come apply the membrane on top of the bond breaker. Everything's dried. Everything's cured, so they say. So then, in what way is that bond breaker meant to work? Is it meant to attach or detach from the corner?
Well, and as I said, it needs to break its bond.
Yeah.
So look, rule of thumb is that anything that is non-paintable is suitable to be a bond breaker.
The word bond breaker.
Yeah. Anything that is paintable, it's not going to allow the membrane to release, or the painted product, whatever it is, that goes over it to release.
Yeah.
Well, being waterproofing, I don't like saying painting, but anyway, it's how we apply the membrane. Yeah. So basically, and you hit it on dry time. In order to use these, when we install these,
what are these, Rob?
These are
MS.
So we've got an MS poly here. It's one of the newer types, like they're leading into hybrids. Trying to get a faster cure time, okay? Neutral curing, and then we've got a solvent based, okay?
So typically it gets used with water-based membranes.
Well,
it gets used with solvent-based membranes.
Well, here at Forspec they do, because it's explained to them. But in other areas out there in the industry, people are just basically grabbing the FC.
Polyurethane?
Yeah. The FC's for fast cure, because they're in a hurry. Good luck with that. And they don't want to wait for it to dry. Right? Now the thing about this is the FC can't really go under a water-based product, because it emits solvents that'll pass through the membrane. Very simple science. What's heavier, water or oil?
Water.
Water's heavier, and therefore the oil is trying to push through the water to get to the surface. But also, because of what it is, it outgasses through the membrane itself.
Rob, I think no matter how many times we explain to someone they can't use solvent-based poly with water-based, and then they go and say, "Oh, but it's never failed. It always works. I haven't had a failure yet."
That they know about,
That they know about.
Yeah.
I think that's still an everyday thing. People haven't shifted towards, or 100% shifted towards MS. They're still using solvent-based polys with water-based membranes. From an experience, going back, some people have ripped out bathrooms, gone to check the corner. It's the water-based membranes turn like chewing gum.
Yeah. Soft
and gooey. So is that the solvents reacting with the water-based material?
Yeah, look, it can be in retarded curing as well, But, if people watch this podcast, James, after I say something, they might go to this and they might start using the correct product, because this has been designed and made to actually cure faster than that. Right? So where they're actually trying to get this as the fast cure, this is a polyurethane. It's 36 hours for 1 to 2 mil to cure. So how much material have you actually got in that junction around your perimeter? And that's most of the time the area of the room that's going to take longer to dry anyway.
Yeah.
And then they go and install this, and because it's fast cure, You know, they think that, you know, when it skins off, it's good to go. Well, you know,
I think it's an old school knowledge of back in the day. Polyurethane was everything. Use it with everything, and it never leaked. So they think.
Yeah, but you know, back in the day, there wasn't as much movement as what there is in today's, you know, economy and how we build. I mean, these things are the most commonly used waterproofing materials. So sealant materials are the most commonly used waterproofing materials, yet the most incorrectly used waterproofing material. Why? Because people actually don't know how to use them. You know, they have a design requirement as well at installation for them to work correctly. Right? And are they being looked into? Do the people know, you know, how to actually install these? Let me ask you a question.
Tell me.
So on your technical data sheet, for an installation of a waterproofing system, when you refer to your transitional changes or directional changes, and you're installing a bead of whether it be neutral pure silicone or your polyurethane or MS fillet, how are you describing that? So in your technical data, and we've got preparation requirements and stuff like that, and you get to this part of it, how do you inform the client in how to install this?
We install it as a fillet joint.
It's a fillet joint.
Joint.
Right. So, but I mean, are you giving them the size requirement? Are you telling them how to tool it off? You know, is it a concave fillet?
No, we like the diagonal.
So on the triangle.
On the triangle,
right, so
15 by 15.
So the triangle gives you that area where you can actually get a more accurate measurement.
Correct.
Okay. There's the concave shape. You know, some manufacturers will actually, you know, recommend a concave shape for that even transition over that area.
But on that point, there's a lot of consultants where they've knocked back installers' work for concave, and then they want the diagonal change.
Yeah, that's a measurement thing, not a geometric thing. Type of, and it's just where you're able to take that consistent measurement from. I mean, if we created a tool, we could get that consistent measurement. It's not a major issue. It's just something that needs to be looked into a bit closer. But the thing about it is that what I'm getting at is in your preparation requirements, are you actually telling the customer or your client how to actually install this, or are you just saying put in a 15mm fillet? No,
we tell them to smear off to get that 15 by 15 and use an inspection tool.
Right. So smear. So you've got install.
Yeah.
No, I'm not having. I'm not having a dig at you. I'm just saying like, and it's not just like it's most manufacturers. They're saying put a 12mm bead in. Okay. So how do you put a 12mm bead in of this? Well, you know, you cut that at 12mm, I suppose, and put a 12mm bead along the perimeter. But then what?
Wait, Rob, we do have a tool. It's called Corkmate.
You do have, yes, I know that. But I mean, does it say in your data, use the Corkmate to achieve, or use a certain applicator to achieve? So basically, and once again, what I'm saying is that there's that ignorance within the industry that's not even explaining to the person, the do-it-yourself or stuff like that. A lot of people out there doing it yourself. They might just come and put a 12mm bead in and not even touch it. Just go, measure that, it was 12mm. You know, they didn't splay it or anything like that.
Because you're saying in the data sheet it says 15 by 15 or 12 by 12, but doesn't actually say the shape.
No.
How to apply it.
Yeah.
I get where you're coming at,
But and this is what I'm saying. So there's no real education around this stuff either.
100%.
You know, we're trying to find out why it fails.
Yeah.
Basically, and it fails. Right. And there's a few things, as I said, it's the mostly used yet most incorrectly used. Does the installer or applicator understand the design requirement of the joint that they're working on? Right. All those things. And if things are done right, and we do the measurement and stuff like that, if we're putting a 12mm splayed bond breaker fillet in internally, and the sheets are being set to, what the manufacturer recommends, which is a 6mm gap on the bottom
for fillet board,
of the sheet, Well, if we put this in at the required size, there's only 2.5 millimeters of material that's actually sticking to that villa board.
Yeah, because you're at that 8 mil.
Yeah.
Yeah, because 8 by 8, which equals 12 on the
you're
diagonal.
you're 8.5 by 8.5 will get you your 12 splay.
Yeah.
Yeah. So only 2.5 millimeters is actually sticking.
So is the 12 mil for a bond breaker or joint fillet? Fillet joint?
Well, for internal, they say that, and because of the requirement, that the 12 mil as a fillet joint internally, yes.
Mm-hmm.
Externally, it's 15 by 15.
Which gives you roughly about 25.
Well, 21 and a half.
Yeah,
It's
21,
huge. It's a lot of product.
Yeah.
And people don't want to do that either.
Yeah.
You know, but it's required for this thing to work correctly. You know, free surface adhesion's another thing with these. You know, as I said, we're accommodating movement, and yet we'll stick it to free surfaces. And if we stick these things to free surfaces, it restricts its movement accommodation by 25 to 33%. So once again, that joint becomes under-designed just by that.
For the movement, for the accommodating for movement.
Yeah. Just by that. Hence, when we go back to it, most used, most incorrectly. If we get onto the bond breaker, you know, there's only two things here that will really allow the membrane to release. That is the neutral cure silicone. This one's just an all-purpose silicone. You know, you can use roof and gutter, whatever. They're neutral cures. That's class 3. And the old cloth tape, which it's got a polyethylene finish. Good to use. It's greater than the class 2.
You're telling me you're going to use that in a bathroom, Rob?
Yeah, it's the bomb.
What, to outline the waterproofing in the shower, or using that as the bond breaker?
The bond breaker.
Sure?
Yeah. Class, in my niches and the like, yeah, it's a class 2. So class 2 bond breaker is a 35 millimeter tape for a 5 mil gap. This is actually 50 mil.
So where would you put that in the corner? How would you put it?
On the 45, so on the wall on the floor, or in your niche, in the internal corner.
And then you wrap the
nice,
membrane
nice
up?
and tight. Yeah, nice and tight.
Yeah.
Yeah. And then you just membrane over that. Now we'll get to how we membrane over this, because remembering, it's not paintable. All right, so we would need to get an even film thickness over this. All right, now I'll explain a few things to you. It's the same with this thing, unpaintable, but we need to get an even film thickness over it. And how do we do that in that transition? It's tough, but we'll get to that. But they work really good. And like I said, 35 millimeter tape for a class 2. This is actually 50 mil or 48 mil, so we're good to go. Right? And the thing about these unpaintable products is that it's very hard to apply a membrane evenly over it.
Because if the DFT requirement is 1.2 mil
dry
film, DFT,
yeah.
So that means if they're doing the NutriCured or the tape, they have to apply 1.2 mil evenly across that surface.
That's right.
So that means if there is movement, it releases from the tape or the silicone, and then you've got that performance in that 1.2 mil to allow for the movement to stretch or whatever it has to do. So that's considered a bond breaker.
Right, because it's released. Yeah.
Because it's released now.
Yeah.
Right,
now the downside of that in using these materials is human behaviour. Right. We're trying to get a nice even film thickness at that transitional change.
Yeah.
It's very tight, but in order to apply the membrane, we need to apply it. We lay it on, but we get into these tight little areas, and we start to use the brush like a painter, and we'll start getting in there with the bristles on the bottom of the brush, the way that a painter would use the brush. What that actually does with an acrylic is it creates little like hairlines or brush streaks going through your membrane.
Which is a weak point.
Yeah, so that when it dries, you're getting film thickness, no film thickness, film thickness, no film thickness, film thickness, no film thickness. And, you know, when it's attached to a surface, you're not really going to see it. But if you release it from its bond and hold it up in the light, you'll actually see, well, you can actually see through it. It's actually translucent. So because you haven't got that coverage. Now, here's the thing. Why the membrane manufacturer requires that wet film, dry film thickness is not necessarily to bring up the properties of the waterproofing, because even like that, it's not going to allow water to pass through it in the form of water. But it will allow water in the form of a vapor to pass through it because it's vapor transmissible. And that's where it splits. It's not going in, it's coming out. So when your substrate breathes, it passes through your membrane, and if you haven't got that dry film thickness, that's where it splits. So if you're holding these things up in the light, and you can see where you haven't got film thickness, that is a weakness.
I think that's the industry standard.
Ooh.
And that's where everyone gets stuck.
Well, it's because they don't understand, James.
Yeah.
You know, and it seems technical in regards to, you know, the membrane manufacturer and stuff like that, in regards to, you know, the explanation of what is waterproofing, what is water resistance, what is vapor transmission, all those things.
Moisture barrier, all those kind of things.
Yeah, well, all those things, yeah, but how that, we're looking at how that membrane works, you know, and when it releases, it's on its own, how it remains, it keeps its integrity in regards to working as a waterproof membrane, not allowing vapor to pass through it and split it in the form of vapor transmission and things like that. Also to be able to maintain its stretchability at those movement junctions.
So Rob, let me ask you, what's a fillet joint?
A fillet
joint? Why this is what everyone uses, or most people in the industry, for what we come across, is they're using fillet joints, and
in the form of bond breaker.
In the form of a bond breaker, unless they're not calling it a bond breaker, they're calling it a fillet joint.
Yeah, okay.
So they apply it to the corner, they apply the membrane, the compatible membrane.
Yep.
And now the compatible membrane is adhered to this fillet joint.
Right.
So the elongation properties must be the same.
Yep.
For it to accommodate for movement, correct?
That's right, yeah. Because it's become a part of.
Yeah, it's part of the whole system. So it's now monolithic.
Because it's bonded to, it's become a part of. Yeah. So the fillet joint's actually a support to that membrane at that transitional change. It's actually supporting it. So what's taking all the stresses and the like is the fillet in itself, not the membrane, because the membrane's not releasing.
Okay.
Right, so all the stress is taken upon it in these materials. The downside of this was that, you know, on top of a screed, and you've got your 12 mil fillet, if that's the size that they did, because they're not going to, because of the tiler.
Yeah.
So once again, under designed, non-compliant, but you know, they don't understand that either. And then if it's too big, one of two things. More, you know, the tiler's going to cut the chunk out. That's more than likely what's going to happen. Or they'll cut the back of their tiles.
To 45?
45, yeah.
Which is not happening.
Well, you know, that's why, you know, the first one, you know. So, you know, once again, it's a lack of understanding and stuff like that. Yeah.
So these polyurethane and MS, they're classified as paintable sealants, correct?
That's correct, yeah.
So not a bond breaker, paintable, doesn't release the bond, accommodates for movement with the membrane. Yeah. So if there is movement, the sealant moves and the membrane moves at the same time.
That's right, yeah.
So is that why you want to match the elongation?
Well, yeah. And that's what they talk about, the compatibility within the system itself.
Yeah.
And we're heading that way too, because, I mean, look, when things change in the upcoming NCC and stuff like that, where we're waterproofing on substrate, you know, are the tilers going to be cutting out the back of their tiles?
No. Well, they're not doing it now because a lot of membrane is getting applied to the screed, because the screed is the substrate that has the falls.
Yeah.
So when they go and apply this, especially external, it's 15 by 15.
Yeah, well,
they've got a 21
it's huge.
diagonal.
Yeah.
The tiler's going in and said, I'm not starting this shit.
Yeah, that's right.
Move on.
So what
do we do in that case?
Well, we've got to look at how we evolve. So, you know, we've got to start to look at, well, you know, transitional bandages. But I'll just give you a heads up with these. If you would ask me, out of the materials that we've looked at in regards to bond breakers here today, what would be the best? So these are the two bond breakers that we've got today.
Yep.
What would you think is the best to use, the most compatible? Now, remembering that all the parts that have to go with the system, what's required, what one works the best?
Depends.
What one is most compatible?
Depends on the system, depends on the area.
No, it depends on getting the coverage over this type of material that's unpainted or that's unpaintable. How do we put something over how do we paint something over an unpaintable material?
That's why it's a bond breaker, right?
Well, that's why it's a bond breaker, yeah, but how do we get a film thickness over this type of material and an even film thickness over this type of material that isn't paintable? There's a way of which we can do it, and it's in the design criteria, okay? If we get this reinforcement mesh or bandage, it's just a basic reinforcement mesh and bandage.
A woven mesh.
Yeah. We can encapsulate this material with the membrane, so we can get our class 2, right? And being a class 2, this is a class 2 in its elongation, okay? So there's compatibility there. We can paint or apply our membrane over the bandage, right? Then we can encapsulate this material in that membrane, so saturate this with the membrane.
So embed it into the wet coat?
So embed it into the wet coat. Now, the thing about it is that this being a class 2, that being a class 2, we can actually use a class 3 membrane to go over this, and all it does is it reduces the elongation of the class 3 membrane to what this is.
Because it's reinforcing it.
Completely compatible.
Yeah.
Required film thickness, peel it off, hold it up in the light, great. You're going to get your dry film thickness. So for your bond breaker requirement, your vapor transmission, all those things, that's going to work, right? We can do that over that, but we can't do it over this.
Why?
Because this is class 3. So by having a class 3 and reducing a membrane over the top of that to a class 2, it's now incompatible. Okay, so we can do class 3 over class 2. So
if you want a class 3 over class 3 without the reinforcement bandage.
Well, yes.
So
Well, they're looking into that now in the one of the new NCC standards where they're talking about a bit more reinforcement in that junction, where they're looking at maybe if you're going to use this, you can then use one of these types of bandages to go over it, because it is a class 3 as well, and it has that same elongation as what this does. And when you put your membrane over it, this is unimpeded, so it's going to stretch to the way that it's designed to be stretched.
So this rubber at the back, Rob, this is flex tape.
Yep.
So on the front side is the membrane side.
Yep.
That rubber part gets to the back wall. So you wouldn't really need this then?
Well, it's not that you don't need
this.
it. Well, it's not that you don't need it, but they're looking at greater movement and the like, and they're actually saying that you can actually put some of this in the class 3 and then put this one over it for greater movement joints and stuff like that. I call it, they say greater movement, I call it paranoia. But yeah, so moving down the lines of these types of materials, because this is completely class 3. It's been designed, the thickness of the material, the design, so the required bond breaker.
So if there's movement, and that's obviously because this is not attached to the membrane.
Yeah.
This gets put into the corner.
Yeah.
So the membrane gets attached on the fabric.
Membrane's attached to there and there.
Yep.
And then completely over the front.
So fully embedded on the front.
Yep.
And then so when there is movement on that right angle corner.
Yep.
So that rubber piece expands.
It expands, yeah.
And then contracts.
Yeah.
Expands and then contracts.
Yeah. So it's not, and it's not bonded.
It's not bonded, yeah.
So it's not necessarily a bond breaker.
Yeah.
Or they refer to it as a bond breaker bandage. In some manufacturers actually refer to it as their bond breaker band or the like. But like I say, if it's not breaking its bond, why would you call it a bond breaker?
Because there's no bond to break at the bottom.
There's no bond to break.
There's no bond to break.
Yes. So so there's several ones like these out there now. There's another one here. It has a different mesh. This one's a mesh.
Yeah.
This one's a...
Typically we use these for water-based membranes.
Yeah.
And then this one was designed for class 3 cementitious membranes.
Cementitious, yeah.
Reason being is that netting allows for the cementitious to filter through.
Yeah, so it's a bit more, viscosity's a bit thicker. Yeah.
And you get a better adhesion.
Yeah, cool. And as you said, class 3.
Class 3.
And this one, once again, it only goes with your 989, not your 988.
Yeah, Acflex 989, correct.
Yeah. And that's once again for that compatibility of that.
Has that got the rubber at the back? It's got the rubber at the back as well.
All right. And yeah, so you've got that accommodating there. And it's the same application process. Keep that unimpeded. All right. And then in your junctions like such.
So they would put a coat on the floor on the wall, Rob?
Yep.
They would then put this into the corner?
Embed that in.
Yep. They would crease out all the creases, air bubbles.
Yep.
And then put another coat on top.
That's exactly right. And like actually correct film thickness that you guys require as the manufacturer.
I think the only problem with bandages, especially in winter time, is the curing time, Rob. The membrane behind the bandage cures at a slower rate because now we've encapsulated everything.
Right. Okay.
And
that's interesting. It's interesting you should go down that way because the way that I see it is that.
what are your thoughts on that, Rob?
Well,
it's been brought up to me before.
Yeah. Well, if you're going to use this correctly, what dries the fastest? This or that?
Once it's encapsulated with membrane.
Yeah. So what? Yeah.
Definitely the bandage.
Yeah, exactly.
Yeah, for sure.
So
For sure.
the other reason why they want to go with this is because they're using it incorrectly.
Yeah.
This one here, if it's installed correctly, well then it'll cure the fastest because once again you're not supposed to be getting any membrane on that,
which is the corner of the wall on the floor. Yeah.
Well, if this other part's got a fleece on it, so that it'll actually absorb and dry. Look, with something that's impervious under anything, it's going to retard its curing time because then it's only going to dry from one side, and that's from the atmosphere. So then, that's just looking at parts of the system and stuff like that, as in what needs the atmosphere to dry. Does a cementitious material need the atmosphere to dry?
Yeah.
Or is it going to dry?
No, it's a chemical reaction.
Yeah, so it's got its own little exothermic reaction where it's going to create its own heat anyway.
Yeah.
If we use a thixotrophic membrane over this or with this, moisture's the
it's waterborne.
Moisture's the catalyst for its curing process.
Yeah, for sure.
So once again, it's going to dry without sunlight. So once again, it's looking at your systems and what they are and what's compatible and how these things need to work, especially in winter now if they're colder months.
Yeah.
How long? Okay, so if you actually undertake a measurement, let's say these have been installed correctly, and we have 8.5 mil, 8.5 mil, 12 mil across the hypotenuse, and that's the mathematical, I suppose, equation for the day is that the square on the hypotenuse is equal to the sum of the squares on the other two sides. And if you don't know that, learn it. But if we actually go to the midsection of the fillet, there's actually 6 mil from the back of the back of the triangle to the hypotenuse. It's 6 mil thickness, right? So if we're going every 2 mil, 36 hours, give or take, how long are these things going to take to dry?
4 weeks.
4 weeks in the winter. You got 2 mil, you got 36, so there's 108 hours.
Yeah.
And that's if it's unimpeded, right? But if it's primed on the back side and you can't get out, you've only got one side that it can dry from, so it's got to dry that back part.
And then you put a membrane on top?
And you got a membrane, so put a couple of blankets on it, stop it from being exposed, whatever it is. You got all those hours just adding up, plus the restriction that you put on, because don't forget, we've got 6 mil polyurethane, then you've gone and put a water-based polyurethane over the top of it at the thickness of
1.2 mil
per coat.
A DFT total.
Yeah. But per coat, it's going on at 1 mil or 900 microns. And you've got to wait for that to dry. So there's another 24 hours to fully cure.
Yeah.
Yeah. So layer up and layer. It's like a Sara Lee cheesecake. How long are you going to wait for the cake?
Peel it back like an onion roll.
Yeah.
But if they wanted to use these, so I would say underscreed.
Well, yeah.
Saying that the substrate has falls for an underscreed membrane. And then if the substrate doesn't have falls and you have to apply the membrane above screed, then definitely tapes would be the way to go
Well, it's a better finish
Yeah.
for the tiler to do his work to. You know,
I'm favourable for tape, especially
Oh.
with cementitious. I would prefer tape with cementitious, even though you can use MS with cementitious membrane as a joint fillet, but tape is the way to go, especially on top of screwed. For
well,
sure.
you know, like ask a tiler because they're the ones that are going to tile over it. You know, ask them the finish that they prefer or what they'd like to use.
Yeah.
You know, these things are where it's going, and more importantly, we're talking about the future. These things have a great movement accommodation built in them, but still the design too. And we're getting away from screeding. So these things are actually going to be on the substrate themselves. You know? These are all right under screed because what we were doing under screed, we were hiding them.
Yeah. And it didn't matter the size of the fillet.
So it didn't matter about the size.
of the fillet because it's screwed with fillet.
Yeah. So we'll just install it incorrectly, and we'll just do what we like, and the screed will cover that up. That's the mentality and the ignorance that is in the industry. You know, I'm going to cover it by a few layers. So what's it matter anyway? You know, I used to start my classes by saying, listen, my name's Robert, this is my phone number, and this is a Class 3 bond breaker. And you don't want to see this twice. Because if you've seen it twice, means that it's failed, and you've had to rip it out. Yeah, which is then damage and cost and stuff like that. You know? So, yeah, as you said, we're moving, and you're talking about bandage and stuff like that. There's a lot of trending towards these types of self-adhesive transitional bandages, reinforcement bandages. And these ones here, they're a type of rubber, which is a waterproof. This is like a butanol rubber in it.
Butanol, Acflex SA tape.
Acflex SA tape, yeah. And so, so it's a butanol rubber, which is waterproof in itself. And the fleece has been put on it so that you can actually allow this to be paintable.
Rob, is that a bond breaker?
No, no. It's a self-adhesive transitional bandage, reinforcement bandage. And same thing is that with the movement, rather than the stresses be so tight, the stresses are, this takes on all the stress, and therefore it's transitioned to these edges here, which is, I think this one, what's this, 120 mil or something?
150.
150, so that's 75 mil, all right, which is all paintable. And the bandage in itself is taking on the stress.
These self-adhesive tapes are pretty good.
Oh,
They cure as you release the film from it as well. So the adhesion gets stronger and stronger. They're good to make corners with. They're just an all-rounder.
I mean, like very, very simple, simple process with these. As you said, make a corner. I've got some scissors.
Where'd you pull scissors from, Rob?
Out of the pocket. Always got a pair of scissors, James. So we'll just make a corner with that, which is just a simple cut halfway, cut to the...
Show the camera, Rob, turn it around.
I will when I get it cut. So basically we've got... So we basically just cut it halfway on one of the legs. So on the bottom leg like such, cut it on a 45, then cut it straight up to the halfway mark of the material. And then what we'll do on this side is we'll just cut that on a 45. And this is how simple these things are.
I feel like I'm in arts and crafts, Rob.
Yeah, it's a bit of, what's that, when they fold all the paper? Origami, bit of origami. So, you know, we're an international company here. We're everywhere. And so basically, so there is your internal corner. Yeah, simple. Right. Thing about this is that if you crease it up that line, like such, what it will actually do is it will actually sit nice and straight up into your vertical corner as well.
Oh, look at that, Rob.
All right.
You've done that before, eh?
Yeah, and if you know, just for the media, as James has alluded to, I've done that before. There we go. Forspec, protective coatings, tomorrow's waterproofing solutions today. All right. And as I say, moving forward, that's where they're going to these things. And look, no membrane, no gloves, nothing on my hands or anything like that. Nice, neat, clean. All right.
I guess it comes down to personal preference, Rob. When using mesh tape, flex tape, SA tape, silicones, Your favourite cloth tape?
Look, it's personal preferences. I mean, it's horses for courses. It's what's going to work where it needs to work.
Yep.
The other part about it too is that, you know, when the old one, and we didn't look at, was that when we're actually putting these types of materials under the screen, right, we're having it, whether it released or didn't release, whether they're putting this under the screed as well, same thing, wanting their membrane to release from the substrate, it was sticking to the back of the screed. So what was the point?
Didn't release.
No,
Didn't release.
it released from the wall and the bond breaker, but was still adhered to the back of the screen. So you know, once again, how do you need this thing to work? And there was a design requirement that we could have actually installed prior to screeding, which is the form that just shows able rods and stuff like that.
Yeah, then it gives you that cutout on the edge of the screed.
Yeah, that
You
allows
install
that.
your sealant.
Yeah,
Your sealant now has a 12 by 12,
Yeah.
15 by 15, and now the tiler can get in flush.
yeah,
Yeah.
you know. So, but yeah, it was just allowing it so that there would be no, the membrane wouldn't be impeded and would be allowed to release, stretch without being attached to the back of the screed. So once again, it's just understanding that design requirement that is required in the bond breaker. Now, you know, how many people know that out there? Well, I'd say not very many.
Maybe after today they will.
If they're watching the podcast here today,
What's
reckon-
what you're saying?
all right.
If what was it, Rob? You said it the other day. If you ever need a second opinion, ask Rob twice.
Yeah. Ask me twice if you need a second opinion on any of this stuff. You know, I'm here. You can always find me here or James. And yeah, look, these are the questions you need to ask when you're looking at your membrane applications. What do I need to use there?
Yeah.
And basically, how do I use it? Because, like you said, if you don't know, you don't know.
If you know, you know.
Yeah, and I don't want to go quoting someone else. But yeah, if you don't know, you don't know. And therefore, if you don't know, you don't know. You don't want to find out because you don't think you have to find out anything. Because you didn't know. Anyway, that's all I got for today, mate.
Nice.
You know.
No, thanks for that, Rob. Just a quick summary. Went over the bond breakers, transition tapes, type of transition tapes. So I think we covered it until the next episode.
Yeah, stay tuned for the next episode. And, look, hopefully you now got an opportunity to actually select the right stuff and install it correctly.